Hello and welcome back to another one of the A-Level Physics Mechanics videos. So today we're going to be doing the much requested projectile motion. So with projectile motion, what does that mean? Well, in real life, things don't tend to move just either left and right or up and down. Generally speaking, they're going to move in some kind of combination of angles. So for example, let's say I have a ball over here and I'm going to give it an initial velocity of, let's say, 10 meters per second. And that is an angle of, let's say, 35 degrees. Okay. So what we can do with that is, if I were to extend this, I can see that it's going to go in a massive arc and land somewhere over here. Okay. Now, what if I told you with just this information, we can work out exactly how far away from the ball, from the starting position, it ends up. So I'm going to call this distance S. Okay, so with this, we have to use, so this is a projectile. A projectile is just anything that is moving through the air. Now, we have to consider two dimensions, okay? Up and down, and left to right. So what I'm going to do is I'm going to take the vertical stuff first. So if I look vertically, do I know what the distance is? Well, you can actually say what the distance is, because remember, this is displacement, not distance. So the key thing to remember here is that this is the vertical displacement. So depending on what we're talking about, like where we're ending up, so if we're ending up back where we started, the same vertical displacement, the actual displacement is technically zero. Because again, just think vertically, the ball goes up, it goes back down, overall it hasn't moved. Right, from its original position. It ends up where it started, so the displacement is zero. Now here's where things can get a bit tricky. If they ask you what's the maximum height reached by the projectile, then your displacement isn't zero, it's some maximum value. So this is specifically, because I'm talking about the end of the arc here. Now what about the initial velocity? Well, we do have it, but it's not 10, right? Because keep in mind, 10 is diagonal. There's a horizontal and a vertical component. So if you go back to the vector mechanics video if you're unsure. But if I were to draw it out like this, I can draw two components. Right? I have a horizontal component and a vertical one. And again, remember, this is 35 degrees and this is 10. Okay? Now, if I want the vertical component, I'm looking for the opposite side. So I have sine 35 equals the thing we want. I'm going to call it x. Over 10, so x is now 10 sine 35. We can work what that is out using a calculator, or we can save it for the end. So it really is up to you. So we could just do, so again, I'm in radians mode, so I'm going to quickly change back over. So again, anytime I use trig, I'm constantly thinking degrees, radians, what am I using? So for now, just for the sake of simplicity, I'll keep it like this. But normally I would actually keep it as is, so I'll keep it as 10 sine 35. So that is 5.74 meters per second. What about the final velocity? Well, this is where things can get a bit interesting. If you are not sure, leave it as a question mark, because that's totally fine. However, I know that this object is going to spend half its time going upwards and half its time going downwards. So its final velocity is actually the same as its initial velocity, but negative. But again, we don't need to include this. In fact, we don't really need to include this either. I'll show you why. Now here's what A is. A is actually super easy, okay? A is always just going to be gravity. Okay? So again, I'm taking upwards as positive in this question and to the right as positive. Since gravity acts downwards, it's going to be minus 9.81, and the time is, don't know. Okay. So what we can do here is we have everything except time, so we can use whatever equation we so please. And the best one perhaps to use might be, you can use s equals ut plus half at squared. Right, so find all the times where s is equal to 0. You could use v squared equals u squared plus 2as to get what, actually that won't give you anything, never mind. You can also use the fact that a is equal to v minus u over t and rearrange for t. So then t is equal to v minus u over a. So we have minus 5.74 minus 5.74 over minus 9.81. And what that would do is it would give you the time of flight for the ball, so for the projectile. So this is another thing I want you to keep in mind, is the language that they use. What's the maximum height means that you're working out halfway along here, so what's the maximum here. If they say what's the time of flight, or how long is the projectile in the air for, you're looking at the time it takes to get to its final position. So minus 5.74 minus 5.74 all over minus 9.81 gives me a time of 1.17 seconds. So this thing ends up in the air for 1.17 seconds. So now, well, how does that help me? I wanted to work out this distance. Well, now I can look at the horizontal component, right? I'll keep it as horiz. S is what I'm trying to work out. Initial velocity, instead of 10 sine 35, will be 10 cos 35. So keep in mind, a lot of these kind of questions that I'm doing, this example specifically, it's a very hard example. However, so in your exam they may give you an easier one, but they can also give you a very hard one. There's actually no limit to how difficult they can make it, as long as it's one of the skills that you need to know. But that's going to be... So here's an interesting thing. What about the final velocity? Some people would say 0, but we're talking about the horizontal velocity. It isn't 0. Okay? And this is the reason why. Acceleration is 0. So whenever we deal with horizontal, whenever we deal with projectile motion, we're making a big assumption. We're assuming there is no air resistance or frictional forces, which means the acceleration along the horizontal axes is always 0. Okay? Now again, in other questions they may introduce air resistance, but it will never be in a projectile motion question. Okay? They might say what effect it will have, that's it. The reason for that is there would be air resistance both vertically and horizontally, which makes it really tricky to kind of deal with. So there is no acceleration for projectile motion questions, unless they specifically state otherwise, which again I highly doubt. So funnily enough, my final velocity is actually going to be the same as my initial one. And lastly, what is the time? Well, the time, this is another key thing, will always be the same as the vertical time. Think about it. If it takes 1.17 seconds for it to vertically come back, that is the exact same amount of time as it takes to travel horizontally, right? Because the ball has to end up here. Does it make sense that it would take more or less time for it to go up and then down, rather than just across? If that was the case, it wouldn't end up in the same place, right? If it took 2 seconds to go horizontally, but 1 point something seconds to go vertically, it won't end up in the same place. So the two things I want you to remember are this, yeah, and the fact that these two things are the same. Vertical and horizontal time is always the same, 100% of the time. It has to be. Otherwise, I mean, you're talking about this object kind of changing into two objects or some weird stuff, okay? The time is always the same. So if you work out the time vertically, you can use that in your horizontal calculations. And if you work it out horizontally, you can work it out in your vertical calculations, which is really important because when A is 0, we can't... all of the equations that have u and v in it become quite strange. You just get v equals u, which, yeah, okay, I can see that, obviously. So that's something quite important. You need to have a time in these questions, and well, when you're working out horizontal things. So that's why the time is the same. Okay, that's why it's a really useful thing to remember. And again, remember, acceleration has to be 0 for horizontal. So now we can use... Again, we don't want to use equations that have u and v in them because I will just get u equals v, which is obvious. So I can use anything I want to work out s. Ut plus half at squared could be fun. So why is it fun? Well, if you look, a is 0, so this entire back thing's 0. So actually what I'm just doing is distance equals speed times time, which again is something that we should be 100% okay with by now. So again, we want to use our calculator to do it. We have 10 cos 35, close the bracket, times 1.17, whoops, 9.58 meters, okay? And again, this is a general example. This comes up in all exam boards, so expect to be able to do this. This is a very hard example, though. Okay, but they can give you weird situations, like this question from the AQA paper. If you notice, this is actually part 2, because part 1 involved something different, which I can't remember what it is, but it's not to do with projectile motion, so I've ignored it. So we have a golf ball that lands in a sandpit, and he needs to hit the ball to get out of the sandpit. So he wants to go from here up to here. Okay. Now for the first part, it just says show that the vertical component of u is approximately 6 meters per second, and it tells me the horizontal component is 8.8. So if I were to draw this out, right? I'm trying to find this, which I'm going to call y, and they've given me x is 8.8, and we know that this is 35 degrees. Okay, so all I'm trying to work out is y, so we can use tan, for example, could be a good one. So tan 35 equals y over 8.8. So then y is just 8.8 tan 35. And again, always drawing diagrams, because that helps you immensely, immeasurably in A-level physics. So 8.8 tan 35 gives you 6.16 meters per second, which is approximately 6 meters per second. So when they say approximately, what you want to do is make sure your answer rounds to that value. So approximately 6 meters per second means that to 1 sig fig, I should get 6, which I do. Okay, and that's all you really need to care about. So even if I got 6.45, it still counts as approximately. The ball is travelling horizontally as it reaches x, as shown in figure 5. So it kind of goes up, and then it really does level off. Assume that weight is the only force acting on the ball when it is in the air. So what do they mean by this? Well, it just means that the only acceleration we have to deal with is gravitational acceleration. That's all they mean by that. Okay, which again is exactly what I said in the previous part. So it's nothing surprising there. It says assume that weight is the only force. Calculate the time for the ball to travel to x. Well, let me think about this. We're going to look vertically. Why? Because I have no information horizontally except what speed it's going. I don't have the acceleration, I don't have the time, I don't have anything else. Well, the acceleration is probably 0 in most cases. So I'm going to look vertically only. Do I know what S is? Nope. Do I know what U is? Well, U is the vertical component which we worked out here, which is 6.16. Now what would V be? Well, V, when it reaches this top, if you look, it says it's travelling horizontally, which means there is no vertical component to its velocity, which means its velocity must end up at 0. Again, you can't assume this unless they give you a hint in the question. Acceleration, well, we already know what acceleration is. Again, I'm going to take upwards as positive because I've already kind of implied that. So it's minus 9.81. Time, I don't know, but that's what I want. So I want U, V, A, and T in an equation. So what could we use? Well, we could use A is equal to V minus U over T. Rearrange that for T would give us V minus U over A. So effectively we get 0 minus 6.16. And again, this is where I said in both of the previous videos, don't be afraid of the minus signs, because as you can see, they're going to cancel out. Just sub it in, see what happens. If you get a math error, then you know you've done something wrong. But don't assume you're going to fail, because that's not a good way to look at things. So technically I could just do 6.16, divided. Actually, should we do 0 minus? Answer, don't know why I looked for that on my keyboard, over 9.81. I'm using the answer button because that was more accurate, and it says calculate the time. You should get 0.63, which I have. So let's do, these are all to 3 significant figures, so I'm going to write 0.628 seconds because it's all to 3 significant figures. And then calculate the vertical distance of x above the initial position of the ball. So now we're just using our same suvat, but for s. So we can use anything we want because we have everything but s. So the most obvious one would be s equals ut That's half at squared. So u was 6.16. Again, always using brackets. T is 0.628 plus half minus 9.81, 0.628 squared. And again, I'm going to use the answer button just to save the most accurate answer we have. And that's plus 0.5 minus 9.81 CR squared. Yep, that's perfect. And we get 1.93 meters. Perfect. So again, they've broken it down quite far for you, and most of the time they will, but again, not always. So the golfer returns the ball to its original position in the sandpit. He wants the ball to land at X, but this time with a smaller horizontal velocity than in figure 5. Sketch a possible trajectory. So one thing to note is the overall energy. If I talk about kinetic energy, that is the overall velocity. So it's the vertical and the horizontal kind of combined into one, okay? So what he's saying is it's going to land in the same position, but with a smaller horizontal velocity. And if you notice here, it's only travelling horizontally, there's no vertical component, right? But at this position, they will have the same energy. So we're not changing about how hard he hits it, we're just changing that there will be less horizontal velocity. And the way to do that is to make sure that there is vertical velocity at this position. Just to go through that again, the overall velocity will be the same, but we want to make the horizontal component smaller, which means you have to make the vertical component bigger. So what we can do is, all we have to do is make sure instead of landing so it lands horizontally, we want it to kind of dip back down. So we could do something like this, right? And at that point, it'll be all vertical velocity actually. So explain your reasoning. Well, all we want to say in this part is, well, why did we choose it? Well, we're going to just say exactly what I said. So one other thing to note is you could also add like a little thing where this is greater than 35 degrees. The idea is that it's a steeper angle. So we can explain our reasoning. So it's 2 marks, so let's think. So a steeper, or let's say larger angle, and I'll label this 1 because again, remember, I want you guys to bullet point your answers, okay? Larger angle at the beginning lowers or increases vertical component, which results in smaller horizontal component. That's it. 2 marks. And again, it's exactly what I said, but it's more precise. So I have the mark scheme open here. So the kind of marks that you get, all you need to do is increase the angle here, and make sure it has some vertical drop at X. So you can't go like up but then still level off here. It needs to go above the point here. Okay? Perfect. Next question. So in areas of the world where a plane is unable to land, free-fall airdrops can be used to deliver supplies. So a plane is travelling at 75 meters per second and at a height of 63 meters. So I actually kind of like to draw on the diagram itself. So it's travelling horizontally, right? It's not a rocket, it's not going straight up. And again, the height is 63 meters. Draw the path of the falling package. Now this is where things can get a bit interesting. If we ignore air resistance, it's going to fall basically diagonally. Okay, so it's going to fall like that. But as it gets, so it's going to start off diagonal, but as it accelerates down, it means that it's going to start curving. So it's going to look more like this. So it's going to be diagonal and then a curve. Okay, and again, so the key point about this question is we don't have to end up in the drop zone, we just need to show it. So at the beginning it's diagonal and then it slows down. The reason for this is we are ignoring air resistance, which means this velocity will stay the same. But, right, and here's a big but, it's accelerating downwards, which means the downwards component is increasing. Okay, so at the beginning we just have horizontal, but then as we start to fall, the vertical component begins to increase greater and greater and greater. Okay, which means it's going to accelerate downwards where it's not accelerating at all horizontally. So in other words, it's going to be parabola kind of shape. And we need to show that the time taken for the supplies to reach the ground is about 4 seconds. So again, if we look at this vertically, why? Because this is just a dropping question, right? This is the same as just if I've dropped something. We have 63 meters for S. The initial vertical velocity is 0. The final velocity is we don't know. A is 9.81 because again it's gravity and we're taking downwards as positive. And we're going to take to the right as positive as well. Why? Because the package is moving to the right and downwards. So if we can avoid negatives, all the better. Also keep in mind that S is a vector that is going downwards. So if you take upwards as positive, S is negative, your velocity is negative, your acceleration is negative, etc, etc, etc. And we're working out time. So S, U, A, and T, so that reminds you of the equation S equals UT plus half AT squared. And remember, this is actually an equation that we always use when we're dropping something, because we can do the same thing. And now T is just going to be equal to, so times both sides by 2, so we get 2S, divide by A, all square rooted. So we have 2 times 63, 9.81. That gives us our value, and we just need to work out what that value is. So square root over 2 times 63 over 9.81, 3.58 seconds, which is indeed, it rounds to 4 seconds. The reason why they always make these show that questions is so if you get this part wrong, you can do part 3 and get full marks. So if you notice, my value for time is different to this, right? That's fine. If you use this value of 4, you will get full marks here, even though your answer will be different if you use the correct answer. So don't worry about that. It's called error carried forward. They're completely fine with it. Even if you use your, let's say you write 1.38, right? So it's not even 4, and you decide to use that 1.38 in the next part, again, error carried forward. They will recalculate the answer using your value, and you can get the full marks. Okay, calculate the horizontal distance. Well, remember, actually, I'm not going to say that just yet. I'm going to give you a chance to think about it while I write out the values. S is exactly what we want to know. U is 75. Where did I get that from? It's traveling at a speed of 75 meters per second. V, I'm going to leave that blank. A is 0. We're going to ignore air resistance. So V is that. But the important one is that time is the same. Think about it, right? We are ignoring a lot of stuff when we do SUVAT, right? So when it hits the ground, obviously it's going to stop. But our equations don't take that into consideration. So we have to use our brains and our logic. So what I'm saying is the second this box hits the ground, 3.58 seconds after it's dropped, it's going to stop. So my time is going to be the exact same. In real life, sure, it might slide, it may do this, that, or the other. But if I increase this value for time, my equation will just keep going. And I can get some really weird values. You can get like negative S and things like that. So you have to use your logic, unfortunately. I know it's a very scary thing. But the times for horizontal and vertical is always the same to prevent anything weird happening, okay? So again, what happens? This box drops, it hits the floor, and instantly it's going to stop moving left, right, up, or down. It's just going to, boom, hit, okay? So that's why the time is going to remain the same. And again, we can use UT, yeah. So again, it's just distance is speed times time. But if you want to know where that comes from, it's just S equals UT plus half AT squared. But again, A is 0. So it's just speed equals, distance equals speed times time. So 75 times 3.58. And again, I'm going to use my exact value just because I can. 268 point... Oh, let's actually have a look, right? So 3 significant figures, 2 significant figures, so we should really say 270 meters. But what I like to do is actually write out like a bit more sometimes, so 268.8 meters. So I like to write this one and then write the rounded version so I can get marks either way. Again, unless it specifies, you know, to an appropriate degree of accuracy, you don't technically have to always round. So you can leave it as that. And yeah, that's all we have today. So hopefully this makes you a bit more confident when it comes to projectile motion. It ain't that bad, it's okay. But obviously I can completely understand the fear. But anyways, I'll see you in the next one.